Thank you for attending the SANIMAS Roundtable discussion. This discussion is a result of the SANIMAS evaluation survey that pointed to the need for new technology. Since 2005, over 22,000 sanitation units were installed in Indonesia under this program. The survey showed that many of the technologies were performing below expectations. This roundtable looks at several SANIMAS technology options, including regional sludge disposal options, innovative toilet technologies, and advanced technologies or implementation for anaerobic baffled reactors, aeration, and connecting the units.
That Islamic Development Bank, like many other development partners, have been supporting the government of Indonesia in the past for this SANIMAS project, and this is one of our flagship program in the country, and we really want to help and support the government of Indonesia to scale up this SANIMAS project.
We would like to share the 3 slides PPT and introduce the GOP, Genic Omni processor. So, okay, being supported by Bill and Melinda Gates Foundation in technical and finance. During the past 3 years, we developed the Omni processor in China. You can check the flow chart on the right side of the PPT. That's the original design from Genic company, now called Saddlon. And we adopt and adjust a lot of design based on China regulation. So the Omni processor, the target is harmless, reduce the volume, and finally reusable treatment of the feces sludge and the domestic sludge. The energy is driving from biosolid into the incinerator furnace, burning and generate the steam. The steam will drive the steam engine linked to the generator and finally give the power out for the electricity. In this way, we can finally have the purified water, electricity, ash, and then at the same time, eliminates all the pathogens and harmful ingredients. All the systems include functions about crushing and conveying, drying, incinerating, steam recovering, water purifying, power generating, and emission control. We can also tailor design for Omni processor emission control sector when we go other countries. The inside incinerator temperature can high as 1,100 degrees Celsius, which can give the possibility to let this system also treat the hazardous waste. That's our feasibility study. So the only disadvantage we talk about today is that we now can only have one model of Omni processor. The daily treatment capability is 50 metric ton per day. Refer this 50 metric ton while mentioning water content of sludge or physical sludge 80%. Omni processor can also treat the sludge from the factories. That's the industrial waste, industrial sludge from slaughterhouse, grease plant, large poultry farms, paper pumps, and mills. So many kind of these industry factories don't have the right choice method to treat their waste.
One of our 2 series is the SW. That's its nickname for clear. The SW series mainly treat civil or industrial or hospital sewage on site. And after that, you can safely discharge it to the ground. So it meets the safe discharge level. And you can say the flow is, we first of all using our oil separator to degrade the oil contents in the dam. The sewage goes into the equalization tank. And after that, it comes to clear sewage SW processor. And within our processor, we have used our self-patent biological system to purify and do the sterilization, everything within this processor. And after that, when the effluent comes out, it can be safely discharged to the groundwater. And if necessary, we can even recycle and reuse it. So here is our the second of our series, that's Clear's TT series. The TT series are mostly compound units which combines both the front end, which is the toilet bathroom housing, and all together combined with our back end. That will be our biological treatment system. And then the main difference from the mentioned SW series is the TT series can treat and recycle and reuse the black water on site. So you can see at the bottom that they can be tailor-made according to the user's needs. And the first four of them are the delivered units within China. The main reason is that our reactor has higher performance than the traditional ones. So we did a comparison calculation. And so our unit saves in average like up to 30% space. And also it can be installed either above or below ground.
I'd just like to offer another technology is that perhaps it could be good for retrofitting the existing small scale or the public toilets treatment, which is we use solar energy to enhance the efficiencies of the septic tank, which is very simple, very self-contained, and then highly efficient. That at least you can get free energy from the sun, and then simply increase the temperature inside the tank. The key of the process would be that just enhance or increase the temperature up to about 50 to 60 degrees Celsius with the optimal contact times. Then you can enhance not only the removal of the organic contents in your septic tank, but also you can inactivate the pathogens, which is much higher than the conventional septic tank. And then the solar septic tank can employ a certain biochemical processing, that so-called the thermophilic process that can speed up the metabolic rate and also can help remove lots of that organic solids. Then the solar septic tank could reduce the cost of this solid processing further, and then the power system would be just simply solar heating, but it's not solar PV. It is just simply a kind of that the solar water heating process that you use in the toilets for bathing purposes, but just apply that into the septic tank. We are proving that our technologies also can meet the requirements. And then we can achieve up to about that 90% of the removal of the organic and solid removals, which is much higher than the conventional treatment technology. And also that up to about 55 to 60 degrees Celsius, we can expect the removal of E. coli inactivations 4 to 5 logs. If considered to be the percentage, it would be 99.999. And if you would like to meet up to the very, very stringent standard like ISO 30500, so that it recommended that to couple with the constructed wetland, which is not just a conventional constructed wetlands, but we have a kind so-called the modified media in the constructed wetlands that we can meet the standards according to the ISO and 30500.
DAWATS for, decentralized wastewater treatment solutions. And we're looking a bit behind, we see it as a progressive wastewater management approach to provide safe and sustainable way of sewer-based sanitation solution to the local context. Over the time, worldwide, the sector has evolved, and so DAWATS did from a singular to a modular system, from individual household solution to interlinked decentralized sewage cluster, from community to public utility operated assets and services. So to put 3 essential steps needs to be followed to have a successful implementation of infrastructure project and programs. Understanding context. Sounds easy, it's not that easy. Establishing a self-sustaining, enabling framework around any assets led by the key questions: who owns, who pays, who operates, who controls. So the last is actually choosing the right technology concept based on A and B and follow state-of-the-art design principles. From designing point of view, DAWATS or ABRs are very sensitive towards a fluctuation of the flow. So if we can control the peak flow, the morning and even the hour peak flows, we can reduce the entire footprint of an ABR and AF by 30 to 50% by placing a balancing tank and having a pump. We have started combining the ABR and AF with an aerobic system, mainly with an aerated fixed bed, because most of the easy food and BOD, COD, it's gone. So, and fixed bed reactors aerated, working much better with the remaining food. With that one, we have the same footprint, but we would need a little bit energy, which is much less if we have a full aerated system, and could meet the standards.
To all the presenters, please accept our sincere thanks for participating in this roundtable discussion. In conclusion, several innovative technologies were presented and have applications in the next phase of the SANIMAS program. They include regional approaches, modular low-energy toilets, retrofitting existing technologies to meet the new regulations, connecting decentralized treatment systems, and several climate adaptation and mitigation technology considerations. Thank you all for participating.